Okay, so just to recap what we've been talking about in our science unit, the properties and changes of matter and substances, we have been doing a few experiments this week, and really you guys have been scientists at home doing these experiments. You have been checking out how to make an egg float, you've been making rock candy, you've been mixing two substances. We looked at steel wool and how when you add chemical to it, it actually changes its chemical state. And the last one was looking at chemical cleaner. So we're going to talk about reversible and non-reversible changes, just to recap. So any change that can be reversed, so it's just temporarily changed, it'll go back to its original state. The actual physical properties of the matter does not change. It just changes physically. That is a reversible change. So if I took this piece of paper and I folded it, that's a physical change, folding it up. I can unfold it and it's still paper. It's still a piece of paper. And even if I cut it, now it's in two pieces, but is it still paper? Absolutely. I could still put it back together. It might take a little bit of tape, but this substance is still paper. The matter is still paper. However, if I took it and took the same piece of paper and I actually burned it, that would change it into a whole different substance. So we're going to burn this piece of paper. It's a little bit windy outside, and I wanted to do this outside because I don't want to burn anything in the house. So now, as you can see, the paper changes its chemical state. It's an actual different properties now. It's not, we can never change this back into paper. It's turning into carbon. That's what that black is. It's carbon, and it is, we'll never get it back to its original state. So I'm just going to put this in the fireplace here. And you can see that it is now a black piece of carbon. So what about our rock candy experiment? What kind of change is that? Is that going to be reversible or a non-reversible change? Well, we did take the sugar and we melted it in the water, and then we've let it sit inside a cup for many, many days. I think mine's been sitting for about 3 weeks, and this is what I got out of it. But check out the sugar now. If I was to take those crystals and put them on a plate and take a spoon or some sort of hard object and tap on it and really crush those crystals down while it dried out, it would be turned back into sugar. Now I added some food coloring. It just colors the sugar. It would be blue sugar, but it would be sugar. So our rock candy experiment was actually a reversible change. So the properties of it are still the same. It's still sugar. It was wet, but if you let it dry out and the water evaporates, it eventually becomes, it goes back into sugar. Now, what would happen if we added a little bit of heat? So inside here is a little bit of sugar, and this is just a little makeshift tinfoil bowl. I'm going to add some heat to it. Okay, I'm going to show you another example of reversible and non-reversible changes. And spoiler alert, this might be the experiment that you chose for your experiment number 4, the one that you had a choice, because we are going to be mixing baking soda and vinegar. But just to show you the difference between reversible and non-reversible, if I was to take you know, some baking soda, just a couple of teaspoons of it, and add some marbles to it and mix it up. Now, does that change the baking soda or the marbles in any way? Do we still have some baking soda here? And do we still have some marbles? Could I just easily take out the marbles from the baking soda? Well, maybe not too easy. But yeah, basically I could just take out each marble, wash them off, and we would still have baking soda in this mixture. It's not like I've changed the baking soda. It is a reversible change when you mix marbles with baking soda. But if I was to take, I think I've got all my marbles out of there. If I was to take some vinegar and add it to the baking soda, now that is an example of a non-reversible change. I mix it up, it's created a gas now, all those bubbles are the gas. I've taken the solid baking soda, mixed it with a liquid, vinegar, created a gas, and would I be able to take that baking soda back and make it a solid again? Absolutely not. It would never be a powdery baking soda again. It's just now a liquid mixture made up of baking soda and vinegar, and eventually that gas is going to bubble away. Now, something simple as making JELLO would be an example of a chemical change. So when you take the JELLO powder, which is a solid, and you place it into the cup, and you mix it with water, mixing a solid with a liquid, and you give it a stir. So what I've done is I've taken the solid and I'm mixing it with boiling hot water, and I'm actually changing the chemical composition of the solid, which was JELLO powder, by adding boiling hot water, and it is now going to be more like a different substance, which is kind of a juicy JELLO type substance. So this liquid is going to eventually, right now it's hot because I've added boiling hot water. I don't know if you can see the steam coming off of it, but it is boiling hot water. You can kind of see some condensation on the measuring cup. Take a look. We're going to add some cold water. In fact, we're going to add some cold cubes. So that's going to make it cool off faster, and we'll get JELLO out of it quicker. We're going to add some cool water to it. It'll become a brand new substance. It'll go from a solid to a liquid and then back into a solid, but it'll be a whole different chemical composition. It won't be a solid as it was in the beginning, as it was in a powder form. It'll be a solid in JELLO form. Hi guys, so I just wanted to create this video to end off our science unit on the properties and changes in substances. So we've talked about states of matter, solids, liquids, and gases, and how everything around us is matter. We are matter, this frying pan is matter, this measuring cup is matter, our pets are matter, everything is made up of matter. It's just a matter of whether it's a solid, a liquid, or a gas, and each of these states of matter kind of behave differently. And sometimes matter, such as water, can change, and the way it can change is if we add heat or remove heat. So for example, in this frying pan I have some ice cubes, and ice cubes are simply just water that's been frozen, right? So if it was to melt, which we're going to do right now, it would turn into water, and in the process of it melting, we're going to have some evaporation coming up because we're going to melt it quite fast. We're going to add some heat. So sometimes adding heat is can change the state of matter depending on what it is. If you heated up a rock, that really wouldn't change the rock. It would still be a rock, but certain types of matter change with the addition and removal of heat. So with these ice cubes in here, I'm going to put it on the stove. We're going to add some heat. I'm going to turn on the burner. That is going to heat up, and as you can see, it's beginning to melt very quickly because I'm adding heat to the ice cube. Now, as you can see, the water is beginning to boil. It's changed from ice to water, and it is beginning to boil, and now what's going to happen is it's going to start to evaporate and turn to a gas. And the longer we keep this on, the more the water will evaporate, change into a gas, and in the end, it'll just be all gone. It'll evaporate all the way, and it'll just be change from a solid to a liquid and then to a gas. Now what I'm going to do is I'm going to turn off this burner. And it's going to stop boiling. Let's see, it's still kind of evaporating with some gas in there. And it's going to start to cool down. And I'm going to take it and I'm going to pour it into these ice cube trays, this ice cube tray. And we're going to turn it back into a solid. So we'll have to wait for that one for a bit.